Wonderful, thank you. So, it's the first time we talk after lunch. So I thought that everybody's relaxed, they had their coffees, it's sleepy, and this talk is a bit intense sometimes. So I just want to try to make sure that everyone's here before I start. So I did a checklist. So you're just going to reply yes as loud as you can. So did you enjoy your lunch? Yes. Yeah? Good. Did you have a coffee? No. Oh, come on. There wasn't any coffee? Oh, it's a shame. Okay, did you update your emails? Did you go through all your spam already? Yeah? Yes? No? Did you check your social networks? You're up to date on the Twitters and everything? Yeah, excellent. So now I can start. Thank you. So who am I? So I'm a grumpy engineer. That's my definition of myself. I'm based here in London. I'm originally from Barcelona, so if you want any recommendations of going there and getting drunk, that's me. I co-founded a company called Ukon, which is a consultancy company. We do Puppet and all things DevOps, which is a big fork of stuff. I've been in these for 17 years, some good, some bad. I hope this one's good. I've been doing Puppet for 6 years now, and I feel old. And also I worked at Canonical, where I created with a good friend something called Metadata service. And I also help architect something that is called Juju, which if you heard of, I apologize for that, really. It wasn't my fault. I also help build the DevOps team at Rackspace. So again, if Rackspace bombards you with emails about DevOps, that's again my fault, I'm sorry. Yeah, I said I've been DevOps in for a long time. So apart from doing all these, I also co-organize another meetup group because there's not enough meetup groups in London, right? So I co-organize this one called London DevOps. And the cool thing about us is that we actually have stickers. So if you want some stickers, come. And we also have some good talks as well from time to time. It's from awesome people like Gareth, Tom Doran, who's over here somewhere. Hey, Tom. And yeah, so please come join us. We do these once a month. The next one is in Google Campus. And the one after that is in Facebook. So these two will be quite big, and we'll try to get some swag for you as well. So let's start the talk. So what is metadata? So metadata could be anything, right? This, for example, here is metadata. It's just a card about a book in a library. So metadata, the definition, it's kind of, but it's like that. It's data about data. It's the data you use to define the data you have. And there's two types of data. So there's the structural metadata. So the data that defines all the unique things about something, like a chair, the height, the size, the kind of wood that it's made of, or plastic. And there's the descriptive metadata. That's the metadata that you use to describe things. So if we apply this to Puppet, you can see, for example, the structural metadata is knowing anything about your virtual machine or container or physical machine, like which architecture does it run, what IP address does it have, and this structural metadata is unique to this machine. So you can't extrapolate this metadata to another machine because it's a different thing. And then you have the descriptive metadata, like which version of Puppet are you running, or which version of Apache are you running, which you are describing something that you want. What's the state that you want that in, or what version do you want that of? So if you look this into a Venn diagram, I love those, so you'll see more of those. You have your unique data and you have your abstract definition, so everything should look like. And the very good stuff happens just in the middle, as usual. It's important to be able to abstract your platform in a way that you can define your definitions on top of the unique data you have, and everything should sync properly. So how do we do metadata in Puppet? To the obligatory Puppet slide. So we can define it in several ways. There's the ones that are integrated in Puppet itself, which are the variables and the facts. And there are the ones that come externally, like higher PuppetDB. So, as I said, this is a beginning talk, so if you know this already, please, I apologize beforehand, but I need to go through all this. So, you have the variables, and the variables, as you know, just define $something equals something else. And this variable will be inside your class, and you can use this for anything you want. The thing about variables is that they can't be overwritten, so you need to be slightly smart about how you define your variables. And as soon as you define a variable in a class, you can access that variable through a global scoping using the full name of the variable. so what is called a qualified name. In order to maintain the scope of these, so variables can be a bit blurry in Puppet because the scoping was introduced after Puppet was already running, so it was an after-factor thing. So the way it works is that you have local variables, so you have, for example, here Web1, Web2, which both rely on the Apache class, and whatever variable you define in the Apache class can be seen by Web1 and Web2 classes. But then anything you define on mail won't be seen by Apache Web1 or Web2. And anything you define in Web1 will be seen only by Web1. So that's the good thing. So variables can be local, you can keep things happy and reuse variables in different classes, just because they don't see one another, so they don't override themselves. Then if you take these one step further, then what you can do is do exported resources. So exported resources, it's not metadata per se, but it's a way of collecting metadata. So what you do with this is that you define a function that needs to be executed in a class, but this function won't be executed on the client itself. It will be executed somewhere else. And this somewhere else where this is executed, it's defined by you. So the way this is defined is by adding this syntax with the thingies and the other thingies inside another class. So when you load this class, what it will do is that it will collect all the resources that you define through that double add, and it will execute that function as if it was written here. So you can get, this is a good way for doing monitoring, for example, if you like to do monitoring this way. You can define all your Nuggets checks in each one of your classes, and then afterwards you just go to your Nuggets class and say, collect all these please and organize it for me. And all of that will go to your monitoring server. The other thing that you have inside Puppet is the facts. So the facts are done through a program called Factor, which is a default dependency of Puppet. So whenever you install Puppet, you have Factor in your command line as well, and you can start checking it out. So what Factor does is that it has some scripts in Ruby that they collect all the data about your machine. So anything that you can think about, from the time zone to the IP addresses, number of CPUs, or which color does the server prefer, green or blue, or, yeah. So here's, for example, something that I ran just yesterday on one of my machines, and I just did this shorter because Factor gives you a load of facts about the machine. So you can see all kinds of facts that can be used here. For example, the is virtual true. In this case, I was running on an EC2 machine. You can use these to say if the machine is virtual, so if it's an EC2 or if it's a vagrant machine or something like that, then make sure you install these packages, or you do this, or you do that. So you can use all these to fine-tune what you do with your machines. So the amount of facts that Puppet has by default is quite good. It covers a pretty good amount of stuff. Even if you're in EC2 or you're in DigitalOcean, I think as well, it will provide you with custom facts about your platform. But if you don't have enough with that, and that's my case because I'm like that, then you have what is called the custom facts. So custom facts are something that Factor will consume. So it can be a shell script that just asks your platform about something, or it can be just a text file that is written there. So for example, in this one, I just written a text file that says role equal web server. And this is something that I want, right? I want to do the proper thing as the Puppet engineers define, and have my roles and have all my profiles, etc., etc. So when I go to Factor and I ask for the role, it will just reply web server immediately because it went there, it checked these, and it worked. So where do the facts live in Puppet? So the facts in Puppet live in its own scope. So you have facts as part of what is called the global scope. So any fact that you normally call, you can call it as $fact name. But the proper way to do this is that to always call your facts through the full names, the full qualified name. So you want to call your facts $colon and the name of the fact. Because this way, if you have, for example, $IP address inside your class, you won't have a collision. You will, if you put $IP address, you will be calling the local variable, not the global one. So Then we have things that are not inside Puppet. I like to call this metadata distribution, and that's my definition. You can call it whatever you want. And the first one that I want to talk about is PuppetDB. So PuppetDB, does anyone here uses PuppetDB? Raise your hands. Yes, yeah, around 20%. Yeah, actually it's good to use PuppetDB. What PuppetDB does is that it collects all your reports, it collects all your exported resources, and it also collects the facts of the machine at running time. And all of this is very useful for reporting, for knowing exactly what happened, how did it run, especially if you have a lot of machines. But the thing that I really like about PuppetDB is that the exported resources in PuppetDB are amazingly fast. So I used to use exported resources 4 or 5 years ago, and they were slow, but really, really slow, because the database that they used in the Puppet Master was SQLite 3 or something like that. And trying to get facts when you had a lot of exported resources was very, very hard. So PuppetDB is not a Ruby script, it's a full-fledged package. So if you are in Linux and you want to use Debian Ubuntu or Red Hat, then this is the way to install it. I won't go too much in depth about PuppetDB because it can do very awesome stuff, and you can break Puppet in many funny, imaginative ways. But the thing that I want you to remember is that what it keeps the reports, it keeps the facts, and it keeps the exported resources that Puppet can search, and it can be used by Puppet client and by your reporting machine. So your Puppet server or your Puppet enterprise server can use these to generate very nice reports for you. So the one I want to go in depth is about Hiera. So Hiera is a metadata collection program that was written by Ari Pinar, who is speaking later, I think, but I don't know if he'll make it today. But Hiera is very useful because the way the Puppet worked is that you only had exported resources, the variables and all these. So in order to have global variables or variables that were crossing across several things, or to use a metadata model in which you had variables that were inherited from other variables, it was very difficult. So you had to create lots of stuff, create Ruby code that wasn't standard and that it broke again in imaginative ways. So it's not good. So Hiera came to the rescue, and it's a Ruby package, so you can just do gen install Hiera. And if you install Puppet Enterprise or Puppet itself from any of the distributions, normally Hiera is already included by default. Then the way Hiera is configured, it's like this. So I would like to talk a bit more about this configuration file. So Hiera supports backends. So Hiera, the only thing that it does is that it has different libraries that it connects to. And then when you request any information, it will connect to the backend that it's active. And it will look for that variable, that information that you want. So you can have more than one, which we'll see later. And then the hierarchy is how you define the way that Hiera is looking through that. So Hiera, whenever it finds the variable that you want, it will stop searching. So it's kind of counterintuitive that you have to put the ones that you want to be looking at first on the first place. I normally do it the other way around because I used to lose a lot of Polish math. So in this case, what I do is that I have a node, and if I want to overwrite any global variable or any variable that I need just for that node, I'm making that node special, which I hate, but you have to have that option sometimes. It will look for the node first. Then it will look for the roles, which is what I really want to use. I want to have everything in a role and everything in a way that is properly automated. And then anything that is usable and available across all the roles, it will be in common, either on the environment, so let's say all the things that are in production that are common, or in common for everyone, so all the uses that are common across every single environment that I have. And then what you do there after that is that I'm just configuring the YAML configuration file. I'm just saying where to look for those YAML files. So the way you define this is that it's common YAML, so it's quite good, it's easy to use. You can also use JSON. If anybody wants to go through that tutor and write JSON manually, please be my guest. But YAML works very well in this case. And here what I'm doing is just defining an example variable that is called food. And whenever I need that variable in Puppet, what I'll do is that I will have here my class, I will define a local variable that will collect that higher variable and just populate that inside this variable. I do this in order to be clear. So what I do normally is that I have all my higher searches on top of the class, and then I just use it across. There's other people that prefer to just put the higher search inside the function that it's already using it straight, but I like to be ordered about data, so be able to see everything that I'm populating first. The good thing about the higher function is that you can also define a default variable. So let's say that I want to look for example if it's there, but if it's not there and you're using that, Puppet will complain because higher will reply nil by default, and it will say, okay, you try to populate this with nil and maybe it's not good or maybe it's not okay, you don't want to do that. So you can add a default variable or a default value for that variable inside here. So higher bar will be the value of example if it's there, but if it's not there, it will be bar. Then the other very powerful thing about higher is that you can define some hierarchy. So for example, I want to have some variables in the common environment because I will always be using these across all kinds of different roles. But then when I go to the role itself, what I can do is that I can define the variable in the role that I will be using, and then using a higher function inside higher itself to look for another variable. So it's a good way to keep your data organized. You can get a bit crazy with these loops, which is not the best recommended thing, but I normally just do one loop and it works very well. The other amazing thing about higher is that if you go to the Puppet Forge, there's a lot of modules that support higher, a lot of them. So for example, in this case, I'm using this model from MTBot, which what it does is that it just creates the uses for you. So I'm using this across all my structure, and I'm just writing in higher all the uses that I want, which is a very nice, very efficient, very clean way to define your uses. So you don't have to have an array of user definitions there. So now that we have all this data in higher, of course, you will have to write passwords in here, you will have to write very sensitive data in here. And if you're doing the right thing, then you are using I would say a code management repository, GitHub or Bitbucket or the local repo. And who hasn't heard of these? So Uber, for example, published some data in GitHub in a gist with users and data to access Uber. So it was available for everyone if they knew the URL. And there's a lot of bots and a lot of different attacks through GitHub that are just scanning for files that are there with clean passwords that they can use. And you wouldn't believe how many people do actually do that. So my recommendation as a security freak is that please don't do that. Don't put any passwords on GitHub. Don't put your address on GitHub. Otherwise, some techie might come and steal your Wi-Fi. But be very careful about what you put there. So the good thing is that Higher already thought about this, which is great. There's a couple projects that I really like. First of all is the Higher GPG, which what it does is that you can use GPG itself and keys in GPG to store your secrets. So the way GPG works, if somebody doesn't know, is that you can just encrypt the data using the public key of the user, and the user will need their private key to decrypt this data. So it's a two-way authentication, and it works, two-way encryption, and it works very well. And the other one that was written by some guys here at The Guardian, just because, well, The Guardian doesn't have any kind of problems with the NSA or anything like that, so they don't need to be secure. So this guy, Tom Poulton from The Guardian, wrote this called YAML, which is very efficient because what it does is that it stores encrypted values inside the YAML files themselves. So you don't need to encrypt everything. You just need to encrypt the value, and that's it. So you can see in clear text the key, and it's a lot easier to do that. So I like a YAML, so I'll explain you a little bit how to use a YAML if you want. So it's a gem package as well, so you just go gem install Higher YAML, and then we have a YAML command line. The first thing you need to do is create keys. So eYAML supports GPG, supports PTCS 7 as well, which is quite good. And you create keys, so the first thing is that please don't publish your keys on GitHub. Yeah, because it defeats all of these. So keep your keys in a secure place. And what you do then is that, for example, what I do is that I create keys per environment. So I decrypt all the information, and every environment has its own key to decrypt it, so they can only decrypt their environment, not anyone else's. And then with this YAML command file, you can start creating your YAML files. So the only difference is that you can use the same files, but they will be finishing in .YAML by default in the configuration. If you don't want that and you want to use your YAML files, you can change that in the config as well. So you can have encrypted values inside your YAML files and it will work straight. So as we said before, Hera supports different backends. So since I wanted this to be big enough, I didn't add all of them here. But you can see here the same backends use YAML in this case, and I'm using the same hierarchy. And then what I'm doing is that I'm giving the data for a YAML, and I'm telling where the keys are. So if you're doing automation heavily, like I do, what I normally do is that I have these keys in an encrypted drive inside my laptop, and then I tell my boot scripts to boot my machines using and copying those encrypted files through Secure Shell to the new machines. So this way I am secure all the way up to the machine. And these files, of course, are protected with proper permissions. So if they actually hack you and they become root, they can see your encrypted files. But it's fine because you have everything automated, you just create new ones and that's it, right? So the good thing about YAML is that it can convert something like this, so you have to put all this complex thing in front, which what it does is that it tells exactly what to do, what algorithm to use for encryption, and then you put something like potato because that's what you want for your password. It's very hard to guess. And then it converts this potato into all of these. So people, when see your files, they get scared. It's like, wow, this is a big thing to decrypt, and it's just potato, but it's fine. So getting a bit deeper into this, so everyone's with me still? Have you published anything to Twitter yet? If you do, please review positively, yes, please. So now that we have all this information, we have to connect all this metadata. So the thing is that I hate personally, and then I try to solve this through mass and then try to through Juju as well, which I failed completely. There's nothing like having your failed projects in public view. So the thing that you have is that if you're automating very heavily, you have your provisioner that provisions your virtual machines or your physical machines. Then you have your Puppet, because you use Puppet, you're here, doing all the configuration management for you. And then you have your monitoring platform, you're using Sensor or Nagios, or you're just checking things by hand because you're old school. And then you have all the services running there, like your Apache, your mail server, your WordPress, whatever you want, right? The thing is that all of these generate different metadata. So all of these know different things about the platform. And how do you connect this? How do you make these guys talk? It's one of the things that is very hard to resolve. And there's different ways to try to resolve that. So what I'll try to do is tell you a lot about the dangers of these and give you little solutions. So let's say, for example, that you have a load balancer that you're configuring through Puppet because you're cool, you know all about Puppet, and you're already configuring your Apache or your Nginx with all the machines that need to connect through that because you're like that. And then you have all these different machines running perfectly, unless you're running in AWS, because then suddenly, wow, one of them is gone, excellent. So what will happen here is that if you're a paranoid like me, you will have a health check as well. And these will last maybe a couple seconds, where you will be sending some traffic to a machine that doesn't exist. But then, if you're not doing that, or if anything else goes wrong, because things normally don't go wrong alone, they go wrong in groups because they're cowards. So then what happens is that these won't be solved until the next time that you actually run Puppet, which is a huge pain in the ass, because 33% of your traffic is being sent to something that doesn't exist anymore. So I feel a bit like that then, right? You can see the other machines is screaming out and crying like little babies, and this machine completely dead, and you can't do anything about it. And maybe it's in the middle of the night, and you don't fancy being woken up, unless you have PagerDuty, product placing. So, the good thing about this is that, okay, I'll just do a small detour here, because I want to talk about something that is quite good and quite nice, a bit, not very beginner, but You guys follow so far, so it shouldn't be hard. And I want to talk about the religion of service discovery. It's amazing. So service discovery, what it does is that it helps you define very fluid platforms. So let's say that you're like me, you're running in Amazon or in DigitalOcean, and these guys now charge you by the millisecond. So each millisecond you owe them 0.1 cent. And you're tight on budget because, hey, who isn't? I want to spend my money on good things like traveling instead of service in Amazon. So I want to be able to use only as much as I pay. So spin up servers only as I need them. So if I use my test service, I just want them to be running the 8 hours that the developers are there, or the 12 hours that the developers are there if they work very hard, which mine do. So what you want to do is to spin up and down machines automatically. And as soon as they're up and they are available, you want to add them immediately to get them to work immediately. So you don't let them have coffee or anything. It's like, get to work immediately, come on. So that's what service discovery is. So it discovers new services for you, and it publishes all these in a way that you can consume that. And you can consume that from your configuration management or from any application that you want. The way this works, if I want to go a bit deeper into this, is that you have the service publication, and the service publication in the end is just a hugely distributed key value database. And this is amazing because, hey, I was talking about metadata, there was no way to communicate all this, but suddenly service discovery gives you exactly that. A distributed key value data, the data store, that it's available on every single machine. So, hey, this is great. And you have a discovery agent in each machine. These discovery agents, what they do is that they refresh this key value global data store, and they run health checks in the machine just to check that your services is running, they're running the way they should be, etc., etc. So as soon as that happens, the checks go okay, you have that service available in that machine. If that machine gets broken for any reason, like for example, fat fingering something like I do, then the service will stop being published. And then no harm done, the machine will be there wasting some money, but the monitoring will tell you, so it's good. So all of these brings me to what I really, really like and what I have been talking about for 5 years, which is metadata unification. It's like breaking the Berlin Wall again, except that this Berlin Wall is all across the place and it's in different programs, and they don't want you to break it because they want to charge you for that. So it's a bit more difficult to break. And the good thing is that Hayera comes to the rescue here. Hayera really is the place where you can do all these. And it provides you, as it has backends, it provides you a lot of different backends, which is a great solution. And you have backends that consume data from your database. So if you're old school, or if you've had this problem before all these solutions came available for service distribution, you can use MySQL, you can use Redis, or you can just ask Hayera to go and do an HTTP talk to a RESTful API interface to get more data. Or if you're in the new way for service distribution and you feel very good about it, you can use etcd or console for this. So the way Puppet will go with this is that I just numbered these because otherwise I forget. So Puppet will ask Hayera for information for a variable, so the Hayera function. Then Hayera will look for the backends, and it will look in the backends in order. So it's very important the order you put the backends there, because it will always check first the backend that is on top. So in this case, I put YAML before console, so it will look on the YAML backend first, and if it doesn't find information there, it will look to console, which is the thing I use, and it will look inside the console key value data store for that. So it's amazing. So I can put stuff there from my programs, from my provisioning management, from anything I can think of, and everything will be there, and everything will be highly distributed, strongly consistent, and everything's available to Puppet. So it's good news. The way the console one works, because, hey, I wrote this one, so I'm shamefully here sponsoring myself. So the way this one works is that you just define your backend console and you tell where to talk to console. The good thing is that console has an agent in every machine, so you just need to tell it, look in your localhost, you have everything already there. And which path do you want to look? So this path, if you look at the console documentation, it's just the places in the API where you can go and look. So in this case, what I want to look for is the services I'm publishing and the nodes I have. So if I do a call to that, then console will reply with JSON. And if I ask for this, a service, let's say the sensor service, I have my monitoring sensor, I really like it. So I say, okay, where sensor is, I need to give some information to sensor. So it will tell me that the service name is sensor and what's the IP address for that. If sensor was publishing more than one machine, these will be actually an array, a hash of IPs. So it will tell you this is available in all these different IPs for you. And then what you do here is that if you're asked through Hiera inside your Puppet class, the reply will be an array of things. So all the things that we saw before, all these different things, will be represented in Puppet through these variables. Service port, service tag, service names. So you can use any of those to do whatever you want. If they come in hashes or arrays, I wrote a small helper function that I said it's not the best, but it still does its job. So what it does there for you, it only breaks down that hash and gives you a very nice comma-separated list, which lots of Puppet modules really like that. So it's good. So the good thing is that this is the deepest thing I was talking about today, so it's fine. So some warnings and advice, just to finish. If you put any custom facts in Factor, just remember something, and I learned this by pure pain and with the help of RAPNR as well. The facts in Factor need to be fast. Factor is called in every single Puppet run, and it's at the beginning. So if you put facts there that take seconds to come back, you are delaying all your Puppet runs by seconds. And if you have more than one fact that takes that, multiply that. So it's not a good place to be, because if you want to run Puppet quickly, this won't help. So I normally always use text-defined custom facts. And if what I want to do is that it's something that is actually variable and dynamic, things that are variable and dynamic in fact belong in Factor only if they're variable and dynamic, but not that much. So what I normally do is that I have a cron and I have the script that updates a text file. So I know it's cheeky, it's not the best way, but it works very well for me. And I recommend that to you as well, because it actually works. Then my only warning about Hiera is how awesome it is. It's amazing. But also be careful of long query loops. So every time you are looking through Hiera, it will do a query loop, and if you tell it to go and look for another Hiera variable inside that Hiera variable, it will go and look again. So you are slowing down things by doing this. So you only do it when it's really, really useful for you and it's very clear for your metadata. All right, so let's play a little game, just because I like games. So raise your hands. So it's a plain, who's the brain? So who's the boss here? Who has the trousers? And let's say that all these different guys, the provisioner, Puppet, and the orchestration, they give you metadata. They can collect metadata as well. So you need to find who's in charge of this. Who's the guy that's running things here? So raise your hands if you think that the boss is a provisioner. Come on, anyone? Nobody likes a provisioner, really? Poor guy. Raise your hands if you think the boss is Puppet. Puppet should be the one that has all the metadata that needs to know about everything in order to run fine. Anyone? Come on, raise your hands. Yeah, some hands here, fine. Good. Raise your hands if you think the orchestration engine that runs Puppet needs to be the brain. Yeah, some more hands, so lots of guys that like orchestration, like that. So in reality, it's your decision who's the brain. There's no good answer, there's no bad answer. I have my own opinions. I'm a very opinionated guy, so if you ask me, I will tell you about it for 10 minutes. But it's your decision. The only important thing is that you keep coherency. Metadata fragmentation is very bad for you. Different things knowing different stuff about your platform is very bad for you. So whatever you do, define one place. Try to work very hard towards having just one place with all this data, and it will do wonders for you. So that's it. Thank you very much for listening to my talk after lunch. I hope I didn't bore you. So any questions, please shoot away.
question on Hira. When you traverse the tree and you hit the node first, and you say as soon as you resolve that variable, you take it. What about for hashes and arrays? Does it do any merge, or will it just take the first one and then stop?
When you have hashes and arrays, that's a very good question, by the way. When you have hashes and arrays, it will actually merge them. So it will add more stuff to it, which is very useful. I normally don't do that because if I do that, then my fellow developers that don't do Puppet every single day will just go, what the hell is this? They don't know where to start. So I try to keep things simple there. But yeah, if you want to do that, it's very useful and it's very cool to do it.
It's more in terms of avoiding duplicating the data in multiple places. So if the role's got some defaults, but I want to maybe override one value, being able to sort of do that, I guess.
Anyone else? I don't think anyone from that side of the room has asked a question today. I don't know if it's because you don't want me to have to run over there, but excellent. Thank you so much, Marc.